the respiratory volumes are going to be showing the volumes inside of your lungs. Because at any given time, you have air in your lungs. Even if you try to blow everything out as much as you can, exhale fully, there's still air in your lungs. Simply put, the diaphragm can't go high enough, and the lungs themselves, the rib cage, can't collapse all the way down. So there's always some air in there. That air is known as the residual volume. So even if you exhale as much as possible, you still have some air left over. Now that's, give or take, it changes from person to person, about 1,000 to 1,200 milliliters. In this case, it's showing 1,200 milliliters. But everything else beyond that, you can either inhale or exhale. It's air that moves in and out. So I'll start with the middle here, this tidal volume. Tidal volume is the normal breath. So it's what you're breathing in and out any day, any time when you're not exercising. So if you're sitting at a table, tidal volume. If you're laying in bed, tidal volume. If you're simply just talking to somebody, tidal volume. Tidal volume, in this case, is shown at 500 milliliters. We'll use that as a default. 500 milliliters will be our default tidal volume. So if it's ever not given, use 500 milliliters as a default. Now, does that mean everyone has 500 milliliters as their tidal volume? No. You might have it at 400 or 300 or 700 or 800. It depends on the person. But just for simplicity, we're using 500 as a default. Now, if you're breathing in and breathing out, breathing in, breathing out, and then you keep breathing out after that normal breath, that's the expiratory reserve volume, or ERV. Now, the expiratory reserve volume, that's going to be the amount of air that's normally in your lungs at any given time while you're breathing normally. You don't really exchange it because it's just sitting there. It's there as an in case or an as needed. So if all of a sudden you need to start really breathing deeper, you simply can exhale further down and then get a deeper breath coming in. So the expiratory reserve volume is the amount of air that you can exhale out after a normal tidal volume. So you breathe in, breathe out, and from that point you keep breathing out. That's the ERV, expiratory reserve volume. And that goes all the way down to the residual volume. Then you also have this inspiratory reserve volume. That's where if you're breathing in, tidal volume, breathing out, breathing in, breathing out, breathing in, keep breathing in. This is the maximum amount you can go above your normal breath. So if you're ever trying to see how deep of a breath you can take, you breathe all the way in. You've gone from your tidal volume up into your IRV, your inspiratory reserve volume. So these four volumes, inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume, is your total maximal lung capacity. Which puts us onto here. So we had the four volumes. We also have several different capacities. Now I'm going to throw this up full screen so you can kind of see the pieces as they come together. You'll notice that we have something called inspiratory capacity here. Inspiratory capacity, if you notice from here to here, that means inspiratory capacity is inspiratory reserve volume plus the tidal volume. So kind of the spacing it works on here tells you what it is. Functional residual capacity, if you notice where it lines up, that's the expiratory reserve volume plus the residual volume. Next one over, you can see it's just residual volume. There's nothing special about that one. But notice above it, that larger one is the vital capacity. Now the vital capacity, if you trace that over and all the way to the top, you'll notice that vital capacity is inspiratory reserve volume plus tidal volume plus expiratory reserve volume. So your vital capacity is the maximum amount of air you can move in and out of your lungs. And the last one over here is total lung capacity. Total lung capacity is all four of the volumes: inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. So these capacities, they all measure up to some combination of the volumes, whether it's 2 volumes, 3 volumes, or all 4 volumes together. But why do you even care? Well, they kind of can tell you some different things. Vital capacity tells you what your maximum breathing capacity is. So if you're trying to exercise or work out, how much air can you really move in and out of your lungs per breath? If you're looking at your inspiratory capacity, if all of a sudden you had to take a really deep breath and hold your breath, how much air could you pull in at that point? Because you can't simply take a breath out and in, you just inhale. So it's kind of looking at how things are working together here. But now, in every one of those, we have what's referred to as the anatomical dead space. Now I have down here, it's about 150 milliliters. That's the rough amount of air that you breathe in and you cannot use. That's what goes into the nasal cavity, the pharynx, the larynx, the trachea, the bronchi, everything down until you reach the respiratory system, the respiratory actual bronchioles. So that entire conducting system doesn't exchange gas. So anything that goes into there sits there and then just comes back out without reaching the alveoli or the respiratory zone is dead space. You can't use that air. So think about it. You take a breath in, everything that's stuck here right now is not functional. You breathe out, it leaves. The alveolar dead space, that's when alveoli stop working. This could be because it just dies off. Pollution gets in there and just causes it to clot up. Mucus gets in there and blocks it. Whatever. This is now something that varies from person to person. Everyone has some alveolar dead space, but individuals that live in a more smog-filled city or smoke will have more alveolar dead space. Together, those are referred to as the total dead space. The total amount of air that goes in that's not functional. The larger the total dead space, the harder it is for gas exchange because less air is actually exchanging back and forth. So we have a few pulmonary function tests. MRV, or minute respiratory ventilation. This is the amount of air going in or out of your lungs per minute. So it's looking at how efficient, how much can you move in and out. This can tell if there's any problems with the compliance of your lungs. Are they stretching properly? Are the muscles functioning and moving properly? Is there a limitation to how large your lungs can expand? So it's helping to look at the functionality of the lungs. Are you able to exchange enough oxygen, bring enough oxygen in and out in a minute? We have FVC, or forced vital capacity. Now this is different from vital capacity because you're trying to forcibly blow the air out as fast as possible. So you take that maximum deep breath in, and then you blow out all the way through the IRV, TV, and ERV. But you want to do it as quickly as possible because you're measuring the forced expiratory volume, or FEV. Now the forced expiratory volume is how much air was blown out in the first second, FEV1. How much air was blown out in the second second, FEV2. How much was in the third second, FEV3, and so forth. It looks at each second of how much air is being blown out forcibly out of the lungs. If the lungs are healthy, that's really quick. But when the lungs start having compliance issues, they don't stretch properly, they don't recoil properly, that FEV starts to slow down, and the whole entire FVC slows down. So it's looking at the physical state of the lungs and how well the compliance and stretch and movement is working. So the idea of forced vital capacity and then forced expiratory volume. Use that per second, FV1, FV2. So some different functional tests there to help look at the quality of the lungs, how they're working, and how everything's functioning. Plus the lung volumes and the capacities as well.